So my camera is like, hi, I will only work maybe if you open up additional software. And I don't know why it's doing this to me. It doesn't always do this to me, but sometimes it decides it's going to do this to me. It does not see my camera. Why do you not see my camera?
Because the camera is being used by something else?
That is always a possibility.
Oh, my camera doesn't work. That's why it is.
Okay, we're going to switch cameras. Because sometimes
That's
that
such
is
a
the
challenge
answer.
for a computer to bring in to use the same video device for multiple things.
Yeah, but it should only be using it for one thing. But apparently on reboot, it just lost this camera.
Yeah, so some device probably locked onto that camera on the reboot,
Yeah.
and now you have to free it. And like for me, I have a USB capture card inside or I have a USB dongle that connects
Mm-hmm.
up and allows me to bring in from my camera.
I'm going to try unplugging and plugging back in my Elgato camera
That sounds
first.
like you're fixing the James Webb Space Telescope. Apparently, I'm a
Oh,
little quiet as well.
okay. That I know how to fix, unlike this camera. Like, it
And then
was
I find
working
I
when I
find
sat
like I,
down.
I mean I use OBS, but I deactivate the camera and then reactivate it, and that will often work. So I just deactivate my camera and then reactivate it.
There, it sees it.
And
Okay,
which
I
was it? Turning it off, turning it back on again?
plugging it back in.
And I'm hearing like a little bit of an echo.
I have no idea why there's an echo.
Okay. Well, as long as people can't hear it. I hear it like just a tiny little bit. It sounds almost like it's coming out of your headphones. But I don't think it's that critical. It's
There's
probably if it's
also
just for me, that's fine. It's not that loud. I don't even notice it
okay. Let
unless
me
I'm like thinking about it.
let me fix some lights in here because I am dark. Okay, I'm just gonna look tired today because I am tired today.
Um, yeah, I've learned something really valuable about myself. Like
What's
I
that?
have to go to bed at 9 o'clock because I wake up at 5 o'clock every day.
On purpose?
No, no, I just wake up. I wake up at 5.
Your body is an asshole.
Well, I mean, time is relative, right? Like 5 o'clock for me is 8 o'clock for someone on the East Coast. So, but if I go to bed at 11, I wake up at 5. If I go to bed at 1, I wake up at 5. And so I just like I have to go to bed at 9 o'clock. And if I go to bed at 9, I wake up at 5. I have a good 8 hours sleep, and I'm well rested, and I'm perky, and I'm ready to go. But if I stay up later, whether I'm playing some video game or whether I'm, you know, like trying to watch the end of some show that ends late, or we're like into a movie or whatever, yeah, just I'm stuck.
Oh
So
man.
like that's it. This is just like now this is my iron rule. Go to bed at 9:30. That's what
I
it is.
Yeah, so my body is very determined that 8 a.m. is not a valid time.
Yeah. No,
So our
I've
bodies
been
are very
going for
different.
3 hours. But you know what? It's because I'm old. Yeah, I'm 2 years
You're a
older than you. So just you wait. You know, 2 years from now, you will too. And there you go. So people are saying it's the same for them. Yeah, it's old man syndrome. Is clearly the thing. Um, so yeah, it's like, do you get the early bird special too? Yeah, I could. I could totally show up at 6 in the morning and get the early bird special. Um, yeah, like I can't really drink alcohol anymore. Like, it just feel like crap. Like, it can, but normally when you drink and you're like, you're a little tipsy, and then next day is fine. Or when you're a
Yeah.
kid, you could drink like a ton, and then you would just get, no hangover. And the hangover started to show up, and now just like it just feel like crap the next day. It's just like it's just not worth it, and no amount is safe.
Oh
So
man.
you've heard that, right? No amount of alcohol is safe now. Like,
No, I hadn't.
yeah. The new rule is ideally none. That there is no health benefit whatsoever to any amount of alcohol at all.
So that whole red wine before bed thing is out the window?
Out the window. Yep.
Okay.
Never true. Yeah. No amount. Like, I think now in Canada, the medical warning is 2 drinks a week, but like that's just going like if you want to minimize the risks. But there's risks, cancer risks, all the way down the digestive system. So from the mouth to the esophagus to the stomach to the colon, the whole thing has increased cancer risks.
So my husband just turned 51, and he's going through well, I guess I need to lose weight and cut back on things that are bad for me.
Yeah.
And I failed to notice how this impacts what I can have. Because this is I'm a terrible human being. I'm going to preface this with I'm a terrible human being. This is my soda can from 2 weeks ago. This is my soda can from last week. This is the still to be open soda can from today that does not match because he has decided to cut back on soda. And I have soda once or twice a week when recording this show because I never have my shit together early enough to make another coffee. And apparently I don't get soda anymore other than the vestigial remains of the last Target run that included
Buy
soda.
some and put it in a fridge. I don't drink pop either.
Yeah.
And Carla does. And so I'll have a sip every now and then, but
Yeah.
I just don't drink it. Like I don't want it, I don't drink it. So it's fine.
Yeah.
Same thing.
He for understandable reasons, because I too have zero willpower, just doesn't want it in the house. And I get that because I am not to be trusted near foods I really like, even if I'm allergic to them. So, yeah.
Yeah. Getting old sucks. All right. Let's move on to this week's topic of Astronomy Cast.
All right. I'm pressing record. I'm missing a button. Where is it? There it is. I'm pressing the other record. We are recording.
All right. Astronomy Cast, episode 669, Challenges to Dark Energy. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. The 3rd episode of our new TV show aired Saturday. And we got it to the station 90 minutes before it was due to computer crashes, because computers know. But if you haven't checked it out yet, it's Escape Velocity Space News. It airs on Now Media. And I'm going to be putting together a podcast version and loading that up later today.
Congratulations.
Thank you.
Amazing. It's been over 20 years since astronomers first discovered that the expansion of the universe is accelerating thanks to dark energy. And in these decades, astronomers still don't have much evidence for what could be causing the increased expansion rate. Maybe there's something else going on to explain it. And we'll get into that in a second, but it's time for a break. And we're back. If you go back into the archive of Astronomy Cast shows, one of the first episodes that we did was dark matter, and then after that was dark energy. I think like within the teens anyway. And we've brought it up a couple of times since then, but I had been expecting in the 15 years that we've been doing this show that we would have something more to say on the matter. But to be honest, not much has been figured out. apart from some really interesting new surveys like the Dark Energy Survey Telescope, the development and eventual launch of the Nancy Grace Roman Telescope, we still have no idea what this is.
One of the things that actually caught me by surprise is I was expecting to spend today talking about the new results from the Dark Energy Survey and the South Pole Telescope. And there are actually two really cool papers that have both come out in Phys Rev letters in the past couple of months that are both clearly we're theorists, we have predictions, there are only two of us on this paper. Please give us the Nobel Prize when our predictions prove true.
Right.
And so we may be getting to the point that theorists are starting to figure out how to get a handle on things, and they're finding answers that may also help confine dark matter, which is kind of cool.
Oh, that's great. So then I guess, what is the evidence for dark energy?
Basically, it comes down to when you measure the distance to a supernova and you measure the rate at which that galaxy is moving away from us using Doppler shifts, we find that the universe is actually accelerating over time, which is not something that was in anyone's predictions, but it was in the math in the form of a constant to the equations of state for the universe. When Einstein originally came up with these equations, there was an integration factor. When you integrate, you have to add a constant. And he assumed that the constant would have a value that caused the universe to be static. A few years later, Hubble came along, found the universe is expanding. Now we have a constant that makes sense for that. But it turns out that if you have a universe that is accelerating apart, that is a value for the equations of state. And so now what we're finding is, in order to explain the geometry of our universe, which is flat, 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 very flat, and an accelerating universe, you have to have 70% of the universe made of something that isn't observable matter. That's about 4.5% of the universe. That isn't dark matter that gets observed through gravitational lensing, gets observed through rotation curves of galaxies, gets observed through the motions of galaxies and clusters. That's 27-ish%. Instead, you have dark energy.
So this measurement really relies on how good the measurements to those type 1a supernovae are.
Yes. And it also comes down to, once we realized, okay, so we have from the Planck observatory the flat geometry, and then you combine it with everything else and you look at the mass density of the universe. The only way to explain the mass density of the universe is to have this extra stuff as well. So you can get to dark energy from a couple of different ways, but to get at the value that we're seeing, yes, that came very clearly from the 1998 observations that the universe is accelerating with time in its expansion.
And we did some coverage on a new database that came out a couple of months ago where astronomers had gone through and recalibrated, normalized all the data for about 1,000 total type 1a supernova measurements, and if anything have gotten even more accurate.
Yeah.
You overlap the Cepheid variables with the type 1a supernovae. This distance ladder is beautiful. The error bars are ever shrinking, and the amount of dark energy in the universe is zeroing in on this. They're really nailing this number.
And one of the wild things about this is we keep trying to find an excuse that maybe further back in the universe, these kinds of supernovas, due to the change in the chemistry, would have different properties. And we do keep observationally finding random exceptions. There was a super cool Type 1a supernova that went off while inside of another star, which is one way to blow up a white dwarf.
You can imagine that would pollute the results a little bit.
Right. But these one-offs that we're finding are super, super cool, but they are one-offs. The vast majority of the Type 1a supernovae are just boring white dwarfs that ate more than they could hold without changing states.
Right. And so I guess one possibility is that the Type 1a supernovae aren't the standard candles that astronomers had always believed, but the evidence is continuing to build that yes, indeed they are.
Yeah.
Except for the ones where one star blows up from inside another star.
Yeah. And
Right.
and so I mean it's just like saying most human adults are between 5 foot and 6 foot. Yes, there are people who are only 3 foot and there are people who are only 7 foot. But the vast majority of us are between 5 and 6 foot. So yeah, it's averages.
All right, we're going to talk about this some more, but it's time for a break. You're going to drink some soda.
Thank you. I am happy.
All right.
As
And we're
happy as
back.
you can be without caffeine.
And we're back. So then let's talk about some of the large-scale surveys that have been developed to try to get to the heart of dark energy. Not necessarily explain it, I guess, but at least to confirm it, map it, try and nail down its parameters.
So the big one with the obvious name is the Dark Energy Survey, which was done from down in Chile, where they observed with extreme sensitivity vast swaths of the sky with the goal of looking to see how the structure of the universe evolved with time. So the idea here is we know that the universe started out as pretty much smooth distribution of particles. It wasn't even anything more fancy than particles initially, with slight over and under densities that were created by sound waves moving through the early universe. That mostly smooth distribution that we can measure in the cosmic microwave background then had to collapse down into galaxies, stars at the smallest scales, but then clusters of galaxies, walls of galaxies, superclusters at the largest scale. And it does that over time. And we have models that basically say, okay, here is the CMB, here is the modern universe, let's fill in between. And the Dark Energy Survey was designed to get at the more recent few billion years. The next survey that is super exciting to look at is HERA, which is being done in the radio, looking at the redshifted 20 centimeter line of cold hydrogen. That the detectors for this, they're looking at wavelengths of light that instead of being just 20 centimeters are instead many, many feet, so longer than us. And in these longer wavelengths, we're able to start seeing how cold hydrogen was distributed in the early universe, start piecing together how cold gas clumped and then got reionized in the era of reionization. And between these different surveys, we're working our way through measuring what was the structure over time so that we can better confine our models and say, okay, was the amount of dark energy constant over time? Was there some sort of a phase transition? Was there a kick somewhere? And these are the kinds of questions that folks are trying to answer is, what observables can dark energy give us that will help us confine our theories?
And so in addition to the Type 1a supernova measurements, they're able to now look at these galaxy clusters. And then on top of that, they're looking at the concentrations of these regions of hydrogen gas. And so you've got like 3 independent lines of observation that theoretically should allow you to map out the amount of dark energy. And
Yes.
is the assumption that they're going to find it? Like I know the dark energy survey is still partway through its survey. You didn't even mention the Nancy Grace Roman. It's going to be launching in 2025.
Right. You don't
And
count your satellites until they're orbiting.
no, fine. Okay. Pamela, put your hands over your ears. Audience, the Nancy Grace Roman, one of its main jobs is going to be to characterize dark energy, doing kind of the same thing that the dark energy survey is, but from space. So we are going to have like this is classic, right? Like if you don't have an easy answer, then you build more instruments, more observatories. You keep trying to characterize the nature of the problem.
Yeah.
Building hypotheses, testing them against your observations, removing bad ideas one after the other, and hopefully trying to pin down the final thing. So we may never know what's causing dark energy, but we'll have it measured to 6 sigma accuracy.
Well, and the other side of it is the particle physics side. So we know that dark energy, whether it's a force, an energy, a field theory, whatever it is, puts into every cubic meter of space basically a proton-ish worth of energy. And so how do you explain that energy existing? And by better understanding the quantum mechanic side of the universe, the particle physics, the vacuum energy, are stereoneutrinos actually a thing or not? This is another way of coming at the fullness of the universe by looking at the smallest factors inside of it.
All right, well, we're going to talk about some potential explanations for dark energy in a second, but it's time for another break.
And I'm going to drink some more soda. Okay.
All right. And we're back. All right. So I guess you found a few papers that have been proposing some alternative explanations that would explain the observations, but not necessarily be new energy that's being injected into every cubic meter of the universe, which I guess sounds satisfying. Like the fact that energy is appearing out of nowhere, that's unnerving. So what are they proposing?
So the first paper in here, I have to look at my notes. The first paper came out from Martin Sloth and Florian Niedermann, where they're looking at new early dark energy. And the idea here is our universe has undergone phase transitions in terms of the energy of the entire universe. So the first massive phase change occurred in the first fractions of a second, where we essentially went from the universe being every basically molecule-sized bit of the universe expanding out via inflation, which we also don't know what is, to be about the size of the observable universe, according to some ways of looking at it. And this massive, fairly instantaneous epic of inflation may have only been one of 2 phase transitions, where there could have been a later phase transition that, if their testable ideas are right, leads through first principles to having a cosmological constant of 72, which is within error bars of what we see for the modern universe, and fixes the discrepancy we see with the old universe.
And so like the idea of inflation,
yes,
happening in just the first fraction of the Big Bang was developed, I think, back in the 70s.
Yeah.
To help explain a lot of the problems with the Big Bang. Like the Big Bang beautifully explains the universe as we see it today, but there are these flaws in the theory. how can vastly separated parts of the universe be similar temperature? There's a bunch of these ideas, and so one of the theories is that in fact there was this period of rapid inflation that carried everything away from each other really quickly, and then it settled down. So I think baked into modern cosmology is already this idea, as you say, a phase change, a dramatic change in the expansion rate of the universe. So it doesn't seem that surprising that there
Right.
could then have been others later on. So when would have this other,
It
they're
it
calling it what, early, what are they calling it?
they're
Early
calling it
dark
new
energy?
early dark energy. So
Right. Okay.
NEDE is the
New
abbreviation.
early dark energy. Right. And so when would this have occurred in the timeline of the universe?
This still would have occurred during what they refer to as the dark times prior to the release of the cosmic microwave background. And and it fits in with the way Michael Turner, who's a prominent cosmologist, now professor emeritus from the University of Chicago, he says there's basically these three unknown pillars of cosmology: inflation, dark energy, which he actually named dark matter, and and so this looks at that early period, makes some solid predictions for temperature details that we should be able to see with enhanced continuing to look at the cosmic microwave background, which tells us everything apparently. But it also makes some finite predictions for what kinds of neutrinos should be out there and what kinds of specific particles we can expect to find, thus also perhaps explaining dark matter. So we have one coherent theory spelled out in a letter-sized research article making concrete predictions. It seems good and just needs tested now, but it's not the only one out there.
All right. Well, let's talk about the other one then.
So the other one is by Alexander, and I'm going to mispronounce this, and I'm sorry, this appears to be a Ukrainian last name, Tkachenko, and the other one is Dmitry Fedorov, and they look at the vacuum energy of the universe. And vacuum energy is something we know is real because of the Casimir effect, which is just one of the best named effects in particle physics. The dude's name was Casimir, but it just sounds cool to say. And what the Casimir effect says is if you take two plates that are capable of conducting electrons and you put them extremely close together, but you're not actually running charge through them and they're not being exposed to any fields, nothing should happen in a vacuum. But the reality is if you put these two plates just a couple nanometers apart within a vacuum, they will either attract or repel due to the constant creation and destruction of virtual particles that are in their creation and destruction, creating a field. So if you have a proton spring into existence as a virtual particle between these two plates, that proton has a field and it creates the effect. Right. And we see this.
Right. Now, and if I understand, like the Casimir effect, like because the gap is so small, the virtual particles of only certain sizes can pop into existence outside,
right,
or as a field outside the plates, and then they are pushing inward. There's essentially a field on the outside and not so much field on the inside, and it's pushing on these plates. And once you move the plates farther and farther apart, now there's room for the fields to appear both in between the plates and outside the plates, and then that force goes away, and it sort of shows you the presence of this vacuum energy that is everywhere. And then it's, it's been beautifully measured. So no one argues with the existence of vacuum energy. The assumption, though, is that the vacuum that this energy cancels out, goes away very quickly, and doesn't provide any ongoing force to the universe.
And that's one school of thought. Another school of thought is no, it's totally providing dark energy like forces. But when they do all the maths, they have consistently come up with a amount that is too large by a factor of 10 to the 120 for the theories that I like the best and that are among the prominent theories. And the best case for getting it down has, until this paper, as far as I know, been 10 to the 30th. And when you're off by somewhere between 10 to the 30 and 10 to the 120, it really doesn't matter. It's a lot. And this is where these two researchers, Tkachenko and Fedorov, they said, well, okay, what if the vacuum energy has a polarizability, that the particles can actually have alignments that affect what can and can't come into existence and annihilate. And they make, again, solid predictions that should be testable if we go looking with new technology that we don't currently have laying around. And it's just one of those nice, simple, elegant ideas of we know stuff can be polarized. We know particles can be aligned. What if just the universe as a whole has this polarizability characteristic to it that we just hadn't been including? And again, with this research, it makes set predictions on what to go look for. It looks at the particles that are out there and says, okay, here's what to see in particle physics. And I don't know which team I'm rooting for more. I like the polarizability one. Well, I mean, that's like, it's two theory papers making predictions. Both of them have only 2 authors. Both papers are clearly gearing up for a Nobel Prize. It's always good to cheer for people, but I guess I'll cheer for both.
Yeah. And so both, I mean, this is, when you think about the winning Nobel Prizes, many of them start this way.
Yes.
That a theorist puts together a paper and says there should be a particle called the Higgs boson, right? And then 30 years later, experimenters are finally able to find it. And this is the same thing. So, I mean, I guess if dark energy makes you uncomfortable already,
this doesn't help.
Buckle up. Yeah. This is, you still got another 30 to 50 years of searching and scanning and trying theories to try and narrow in on an answer to it.
And if you want to get a feel for what it's like within the field of particle physics to watch people so clearly chasing Nobel Prizes, watch the movie Particle Fever. It is very delightful. Shows the good, the bad, and the ugly of scientists being scientists, and just the joy that comes from people getting to see their dreams come true through instrumentation.
Check that out.
It's really cool.
Yeah, that's awesome. All right. Well, thanks, Pamela. I hope within the lifetime of Astronomy Cast, we will do the show. We finally know what dark energy is. After we do the show where we say we finally know what dark matter is, we will do both those shows. This is my promise to all of you.
And this is where it's just sort of like we can hope. And when that finally happens, is that when we retire?
No.
Okay.
Because there'll be 100 new
mysteries. We keep going till we die.
Yeah, there'll be 100 new mysteries that are even more complicated and more troubling. So, that's how this whole process works. All right, Pamela, thanks a lot.
Thank you. And thank you to all the patrons out there. I don't actually have a thing of names I just discovered to pull out because it's the very beginning of the month and the list hasn't been generated yet. But I do want to say thank you to all of you. We've been reading the names of just a subset of you on air. It's one of the perks associated with the different levels. But we love all of you, whether you're a $1 a month contributor or a $100 a month contributor. You allow us through your ongoing efforts year after year to allow us to pay our humans and keep this show going and occasionally replace cables for my camera when they die. So
So,
thank you every month. So
and
thank you.
I will take this opportunity then to sort of mention a trend, a disturbing trend that you who are a fan of educational content should be aware of, and that is artificial intelligence generated
Yeah.
content. That more and more websites are moving to this model of
Yeah.
getting Chat GPT and other artificial intelligence to generate en masse the material. And this trend is going to accelerate.
Yeah.
And it's just another career that is going to be
Go away.
go away, sunsetted. The career of the science communicator, and that's because it's way cheaper to let a large language model generate explainer content, and hopefully, Pamela and I have value and
Yeah.
place in this society as more and more of this content shifts into being generated by enormous databases. I know
We
it sounds shocking and
no.
surprising, but this is where it's all going to go, and it's going to happen startlingly fast. So,
We've had people write in and say, "Hey, why don't you switch over to using ChatGPT to generate your
right,
scripts?" It's already
yeah,
people are
I,
suggesting it.
yeah,
We
yeah,
won't do that.
yeah. Well, I will get ChatGPT to recommend ideas, but I won't. Here's the here's the key: there are no scripts. That's the
Right,
trick.
right.
So how could we have a script if there are no scripts? Smart. Anyway, so if if the work that we're doing, like if the loss of science communicators at the mainstream media was already troubling to you, now they're coming for all science communicators. So
Yeah.
if supporting the work that we do is important to you, to make sure that we can keep doing the show, paying the people on the team, keeping the servers running, all of that, join our Patreon.
Thank you.
Patreon.com/astronomycast. Thanks everyone, and we'll see you next
Goodbye.
week.
Okay, and then they saved. That button and that button and that key combo, and I'm going to put it in the correct folder.
669.
I thought it was 668.
No.
Okay. Okay. Yes.
I'll need Lindsay's mailing script printed. Whenever you get a chance.
I will need to print things when I'm off air, is what I'm being told.
Okay. Let me do my upload, and let's tackle some questions. And if people don't have a question, then they get a rant. Although it was almost a rant, wasn't it?
I mean, it like when I saw the suggestion, it was from a very well-meaning individual who knew, because Escape Velocity Space News is scripted, that I've been working my ass off, and that we're also really having some funding issues over at CosmoQuest, so that basically it's not so much earning money as working enough, having the funding to cover enough hours to stay benefits eligible. And so we've been struggling. And so the question was, well, why don't you just move to Chat GPT so you don't have to work so hard? And it's just like, no. Yeah. I have a distinctive voice where people can read something I've written and they know it was mine. And
Yeah.
I take pride in that. And
yeah, it's so like I've played, like obviously, I've played a ton with all of this stuff. And the problem today, like just like the logistical problem, is that it is often wrong and lies. So it's very confidently wrong that you can't trust it.
Mm-hmm.
That feels like an issue that will get sanded away. Like people will figure out how to make these things both confident and correct. And the writing style is fine. Like I think it's legitimately going to fill this hole, and I think a lot of just like text-based content is going to get done with it. And like the only place that I've been able to find a use for it so far is when I need a brainstorming partner that doesn't get tired of my questions. And so I will say, like, like, what are 10 ideas for stories or articles that will help me explore this topic? And it will come back with a whole bunch of ideas. And I'm like, ooh, that's a good idea that I never thought of. Okay. And then I
Yeah.
will tackle that idea. So I think that's the value that it has today. But like, I was talking to Carla this morning about this, that have you seen the Seinfeld, the AI Seinfeld channel on
No.
YouTube?
Uh-uh.
It got banned. Because it was making, but essentially the whole thing is artificial intelligence generated Seinfeld scripts, and then it has like 3D graphics of the characters moving around the different, like, Jerry's apartment, then he's doing a stand up, and then, right, all of the
Yeah,
sets,
yeah.
and they're terrible, like, it's just awful, and now, and apparently, like, also a little racist, right? But um but still, like it's garbage, but it exists, and
Yeah,
so you can imagine this getting better and better and better, the way all these processes happen.
yeah.
And someone else was talking about how inaccurate ChatGPT is, but if you just bolt it onto Wolfram Alpha,
Right.
it can double check all of the underlying data and get answers that are very correct. So,
Yeah. There was an interesting piece. I want to say it was NPR on Friday. It may have been a different day of the week last week. It was all Blur's Day, where they were talking to, among other people, some rocket scientists who do the calculations to make sure rockets end up where they're supposed to end up. And they were talking about the difference between how we can trust, like, curiosity, perseverance, to look at their surroundings and not self-destruct on their surroundings. But we only let them go so far.
mm-hmm.
And then they asked, I believe it was Chat GPT, to describe all the rocket equations. And it basically came back with the main equation that is lift to mass ratio and all of that,
Right.
and then bungled everything after that. And so the question is, do you trust a generic algorithm? No. Do you trust a hyper trained with boundary conditions, can't really call it artificial intelligence so much as well-programmed decision trees? Yes, we can trust the well-trained decision trees. We're at this weird. Where is the boundary between the machine learning and the hard-coded but complex?
But I think, like, at the pace, like, there's always this joke in artificial intelligence that whenever artificial intelligence demonstrates something that was always thought that only humans could do, playing chess, playing
Yeah.
Go, recognizing cats, etc., then people move the goalposts and say, well, that's not really artificial intelligence, but here's this other thing that computers will never be able to do. And then a year later, computers can do that. And so they move the goalposts again. And so you can read an article that is written by artificial intelligence, and it is pretty good. It's now
Yeah.
passing the bar exam. It's passing the various, the LSAT, various tests
Yeah.
that people take. These things are getting good enough. And that's just the generic model. It hasn't been trained specifically to try and take on these tests. It's just, it's
It's
able to program, it's able to give you a recipe, and it's able to pass the bar exam.
Yeah. Folks don't know
But,
how they're going to grade university homework anymore, because
right.
how do you differentiate between what ChatGPT can do and what your average 17-year-old can do? Turns out ChatGPT is a solid BC student.
Right. And so I think, like, to put a line in the sand and say this is as far as AI will ever get is bonkers.
Yeah.
It'll cross every single line, every definition that you give, it will cross that and race forward, gobbling up more and more of what was always thought to be human behavior, human
Yeah.
capability. And like I was talking about that Seinfeld show, and you can imagine, like, obviously it's crap today, but there will be an endless sitcom that looks pretty good and it's pretty funny.
This is how
And
you get Fahrenheit 451.
sure,
Is you have the technology generating the allowable content, and you get rid of everything else and don't allow free thought. The other side of this is where you have to really start asking, how do we prevent the removal of all the skills that we learn when we're writing, when we're creating? How do we make sure that people are still learning the problem solving skills that are needed? There's so many Star Trek episodes, science fiction books, and everything else about the society that is getting all of its needs met by the technology. And
Wally.
yeah.
But I think we take the Copernican principle to intelligence, right? Like, I think fundamentally every defense against artificial intelligence is, the gist is, humans are special.
Yeah.
And the universe tells us you're not special. Right? You're not special. You thought you were special. You're not.
No.
And humans are not special. And the things that the computer, everything that humans thought they could do, computers will soon do. And what does that mean to be human? Are we pets? Are we, even if we maintain control of the technology, are we pets? Are we pets in control, right?
And this goes back to that idea from Caprica, which I know you didn't watch, of everyone's life can be boiled down to receipts, recordings, so many megabytes or gigabytes of content. And if ChatGPT is trained by reading the internet's text, how far are we from being able to train a machine to respond just like you or I would in its shopping, in its responses to its email?
Like, we're a year away.
Yeah.
For that.
And this starts to get back to the Revelation space concept that the book you've been talking about the past several weeks, so I broke down and started reading it, of you can have the alpha version of someone that is Turing complete in software.
Yeah. There's a scene in the second book.
Not there yet.
Where two people have to negotiate, but they're on spaceships that are light years apart, and so they send, light days apart, and so they sort of light weeks apart, and so they send an alpha simulation to each other, and then they negotiate with the alpha on each side. And then the alphas and then both sides are updating each other as the negotiations continue, so that when they finally meet, the negotiations are already complete, which is awesome.
Yeah.
Right. And so obviously there are all kinds of, again, with just incredibly disruptive technology, there are all kinds of really interesting, fascinating, like imagine, like, we're watching these well done video game television shows for the first time. The Last of Us, literally for the first time in human history, someone has really adapted a video game. Imagine you sit down and play a video game, and then you're like, and now I want a movie, please.
Yeah.
And your artificial intelligence goes, no problem.
Yeah.
Here we go. Let's watch a movie. And so and it spins up a movie that you then watch, or a television show, or a comic book, or you play the sequel video game, and it's just all dreamed up by an artificial intelligence right in front of you. And we can't talk to each other about the shows we watch anymore because it's completely personal and unique to each one of us.
Well, and this is where it gets to also the questions of who owns a style of art, because
Hmm.
where they're with so many of the different Lensa and oh, what's the Discord based one?
Oh, the Mid Journey. Yeah.
Right.
Yeah.
If you have a comic book, you can pretty much create a dream version of the comic book starring your favorite
Hmm.
actors using this
Yeah.
artificial intelligence.
Yeah. I definitely have a problem with people feeding artwork from a specific artist that didn't
Yeah.
ask to be included into an artificial intelligence, and then a person can create artwork that is if that artist had drawn it themselves, like, and
Yeah.
without their consent, without any kind of monetization. Like, there's a big court case that's going on right now to do that. And I think it's definitely because, like, and the argument that you go against it is like, well, you can't copyright a style, right? And so if I
Sure.
go and I sit down and I learn to draw like some famous artist and I practice their style and try to, I'm not breaking their copyright. But computers do things at a level of scale
Yeah.
that is not the same, and it's not fair. And so I think I definitely don't think it's right, but to just train on people's style so
Yeah.
that you can just remove them entirely. Like,
Yeah.
you clearly found value from their work, and yet the value you're doing is just to knock them out of the picture. So I think someone needs to figure that out. But I think the default should be your material is not included unless you agree to being included. And that
Yeah.
might be the only way to include you is to pay you, right? They're going to have to pay this artist
Pay for the rights.
$10,000 for the rights to include their information in the training set.
Yeah.
That would be fair. And it's not fair right now because people are going to make a shed load amount of money off of this now. And it is this
Yeah.
arms race. Like I think everyone was always worried, like, oh no, right? But there's going to be, people are going to be ethical about it. They're going to be really careful about how they, but no,
No.
it is full bore.
Yeah.
In fact, like BuzzFeed said that they were going to be using artificial intelligence
Mm-hmm.
to create a bunch of their content, and their
Yeah.
stock price doubled.
Yeah.
OpenAI has had the fastest growing user application in human history. Google is going to probably be announcing in 2 days their version of it, and it's apparently like a code red emergency at Google that they don't have something like this. So, so I think we are in now for the unfettered version of this technology, which is too bad because the consequences can be dire. As Series Cagle was noting in the comments, that like once the technology has the ability to improve itself,
Mm-hmm. Which it does
that's when it,
now.
not to that degree. Like, you can't make you don't have an artificial intelligence that can redesign itself and get a 10% improvement, and then another one that can
Yeah,
redesign
that's
itself and
true.
get a 10%
That's true.
improvement. Like, you still have
You
to
have, they
find a
can
big data.
write, they can improve other people's code.
Right, yes, but they can't improve their own code yet. But
Yeah.
if you get to this loop where the computer improves its code, it gets access to more resources, it gets more efficient, and the cycle continues, and then we got a problem.
Yeah.
So,
This is how we get Cylons.
right, yeah, yeah. But ones with an actual plan. So it's weird. It's a weird time. Like, it's such. I mean, part of me is excited because I love to see new technology and I love to see how this stuff changes, and it's kind of magical. Like, you play with OpenAI and it is magical. You
Yeah.
play with Midjourney, you play with these things and it is magical. I want to see a picture of an elephant in a spaceship. Boom, done. Here it
Yeah.
is. I want to see Jupiter turned into a sandwich. Um,
Crow
I
is
want to
a
have a
king.
conversation.
Crow in a Renaissance style. No, it was chicken.
Chicken.
Shannon McGuire was doing a whole bunch of stuff involving chickens on
Right.
her Twitter feed. And it was just sort of like, all right, we now know exactly how far you have to go before it stops actually looking like a chicken and stuff like that.
Right. Yeah. Yeah. So on the one hand, it's magical, and on the other hand, there are consequences.
Mm-hmm.
So,
Yeah.
and we don't know how to control it. Like this is the control problem, and it's interesting because there was a paper that came out that showed that like with ChatGPT, when you train the ChatGPT, it starts to lie at you more and more believably. So the better it gets, at lying, at
And this
hiding its true capability,
and this
which is
has a
kind of
lot of
unnerving.
consequences for social media bots that are out. Basically, you can create a bot to react to anything you want from whatever perspective you want. If you wanted to create something that would respond to every single one of Stephen King's tweets in the style of Laura Ingalls from Little House on the Prairie, you could do
Yeah,
that.
yeah,
And
no
that
problem.
wouldn't be destructive to society, but you can do that in so many destructive ways.
Yeah, there's a science. And were you telling me this? There's like a science fiction series. Maybe it's a Neil Stevenson book, where in the future, these
Yeah, it's Neil
these
Stevenson.
it's no,
It's
yeah, these large language models are generating text, and the problem is that the text has to be so subtle if you're going to try to influence people because they've got systems designed to watch for this kind of misinformation. And so it might be that you're writing treatise and stuff and it's all legit except for just the occasional word here and there designed to influence people one way or the other because there is this arms race in
well,
generating it and detecting it.
and people are using filters to only allow them to see content that fits their worldview.
Yeah,
And that's even more dangerous.
possibly. Anyway, it's a weird time. It's
Yeah.
a fun time. It's a
No.
scary time.
Yes.
And I am equally excited and horrified and nervous. So
I played a
we'll see how we
lot
go.
of Minecraft after looking at Twitter yesterday.
Yeah, yeah. I don't. So I'm not using Twitter anymore.
I need to get on Mastodon. That's
Yeah,
actually on my to-do list for today.
yeah. So I have this whole testing infrastructure that uses Twitter, and I've completely extracted from it, and getting good timing because they're shutting down their API,
Yeah.
and so now I'm doing all of this stuff on Mastodon. So now the only thing I use Twitter for is to promote the stories on Universe Today, and I don't actually do any other interesting stuff on Twitter. I do everything over on Mastodon, and it's great.
Yeah.
Mastodon is wonderful.
It's
We
not
rolled
in
our own server.
Hootsuite yet, is it?
I don't know. We rolled our own server,
Cool.
so yeah. So I have one. So there's just me on my own server, which allows me to moderate very easily.
Very cool.
Yeah, yeah, yeah. It's not open. You cannot join my Mastodon server. Go find somewhere else. But but I promise that my Mastodon server won't cause you problems. It will not be a troll farm. And I think
Okay.
that's the way.
Oh,
Um,
man.
there's no
Yeah.
ads. There's no algorithm. Yeah, I'm really enjoying it, and the community and the conversations are wonderful. Yeah, dramatically. Like it feels like Google Plus in back in the day.
So the thing that I'm hating is Twitter was used to spread democracy and to help out during crises,
Hmm.
and
Well, those days are over.
Mastodon doesn't have that
It
up.
has a capability.
It's not there yet, and I don't think it has the same SMS to post things feature that is so important during a crisis.
You have whatever anybody wants. Like that's what's wonderful about this open Fediverse, open software, this loose affiliation of like the downside is that you can't use it for free,
Yeah.
right? That whoever is hosting the Mastodon instance is paying through the nose for everybody's chat, all of the pictures they're posting, all the videos they're posting. That 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 is like there's a reckoning for anyone who sets up a server. It works for
Yeah.
me because because I know how to host a website. I know how to pay for the costs of hosting, etc. And it's not much, right? Like maybe it's an additional couple of dollars a month for me to handle all the bandwidth that we're creating.
Yeah.
But no, all of that technology that you're like, it absolutely has the capability to handle any of those same applications. So I think that's all that potential is there. It's just a matter like Truth Social is built on Mastodon. So if Donald Trump and team can take advantage
I
of
did
the
not know that.
platform, yeah, then anybody can. So no, I'm really excited by it. I think it is the final evolution of the social media application.
I
And
remain
it's like,
sad.
I don't. I have no love lost for Twitter at all. So yeah, come on over to Mastodon. Have fun. All right, we better wrap. We've gone 5 minutes over.
Yeah,
So,
yeah.
where are you? So I am at Fraser at m.universetoday.com. That is my account. But if you search for Fraser Cain, I'm sure you'll find me on Mastodon.
Mine is in my Twitter pinned tweet, and I don't even remember what it is. So,
There you go. All right. Thanks, everyone. Thank you to everyone watching us, both on YouTube and on Twitch. Thanks to everyone who, all of the moderators. Thanks to all of the people behind the scenes who help keep this show going. And thanks, Pamela, for bringing the brain. And we will see all of you next week.